All right, let's work our way through the multiple choice section of exam 2. So here we got a question 1, and note that this is tech active, but we'll see where we might use tech and where we might just be quicker if we don't use tech. So this one here looks to be an equate the base type problem, so we'll go that and 3 to the 2. So common bases being multiplied, what we do is we add the powers. So let's say that the answer is 3 to the 2x plus 1 equals 3 to the 2, 2x plus 1 equals 2, 2x equals 1, x equals a half. Okay, this one here is equivalent to, so we've got a subtraction here. All right, so this one, what we'll do is we'll rewrite each of them by grabbing that and putting it out the front there. So it's going to be log a or p log a m take away or add p log a m. So that's going to be those two. So we got one instance of that and one instance of that. So we're sticking them together. It equals 2p log a m. Okay, graph showing it right with turning points there and not turning point there at the origin and -6, 0. The set of x values for which f dash x is greater than 0 is. So we want where this graph has got a positive gradient, which is from there to there and there to there. Now, we don't include the 0 gradient points because we want where f dash x is larger than 0. So be careful about this question versus a question that asks when something is strictly increasing. So this one's going to be from negative infinity up to -4, not inclusive of -4, 0. There's our answer there. Okay. All right, this one here, we want to diff this. Might be quicker to chuck this one in the calculator. Expand 2x take 1, x squared plus 2, and diff ants. All right, equation of the normal to the curve at the point. Right, this is way quicker if you do this using line and normal. You give it the expression 7x take x squared, and it's when the value of x is -1. We don't need the y coordinate. So we hit OK, and there it is there. Now we just check whether any of them are in that form, and none of them are. So I just usually then write y equals -x over 9, take away 28 over 9. 9y equals -x, take 28. It looks to be this one when these two are added to both sides. All right, straight up simplify here. So that 3 to the 3 is 27. X to the 6, y to the 12 over 9, x to the 2, y to the 6. So it should be 3, x to the 4, y to the 6. Okay, amplitude and period. All right, so y equals -3 sine 2 x plus pi on 2, take 4. All right, so our amplitude is 3, so these are the only options. Then we've got this 2 here, so the standard period of sine is 2 pi over 2 equals pi e. The value of cosine of 60 degrees is not the same as -60. 420 is 360, That's the same. Sine of 30 and cosine of 60 is a half. 120, sine of 120 is the cosine. I think that is our answer. Sine of 150. Ugh, I'm just going to chuck this into the calc. Sine of 120. Yeah, there you go. So cosine of 60 is a half. So there's our answer. When converted to radians, 210 is closest to. Okay, so 210 is down here. So that is 3.1 roughly radians. So 210, I think it's going to be this one here. Well, let's just do it anyway. So we've got 210 multiplied by, what is it going to be? 180 on pi, pi on 180. 180 on pi. Pi on 180, shift. Pi on 180. I never remember which way to do it, but I know the answer is going to be roughly 3.6, I think. I don't know whether I've got this right, but let's just see. There it is there. All right, this one, the average rate of change. Okay, so for these ones here, define f of x equals sine of 2 shift pi times x plus 2x. And what we'll do is we'll do f of 5. Actually, let's do a shift divide. F of 5 take away f of quarter all over 5 take away quarter. What happened there? Define the function correctly. Sine, oh, yeah, good one. Okay, moral of the story is make sure you're in the correct mode. Okay, graph of the function has x-intercepts at, so between 0 and pi. Okay, so probably the easiest way to do this is solve for tan 2x equals 0 for x between 0 less than x less than pi. Pi on 2, there. Okay, the range of this function, so it's an exponential function gone down 1 unit. So I think the range is going to be -1, which is asymptotic at, to positive infinity. Y is an element, -1 to positive infinity. Okay, yeah, some of the solutions problems are pretty common on VCAR papers. We're going to go solve cosine 2x equals 1 for x between that cosine 2x equals 1. We need to include those. Maybe that's why. Oh, there we go. It's sneaky. All right, so we're going to put pi and 2 pi and 0 together. The answer is 3 pi. Okay, particle moves in a straight line so that its position x centimeters from fixed point O at time t seconds is given by this. The time when the particle is first stationary is when t is equal to. So this function here is the displacement. Okay, so what we can do here is if x cubed take away 9x squared plus 24x take 1. So that's the derivative function. Solve answer equals 0 for x. 2 seconds. Okay, another way to do this one would be to grab it and go into your graph and table. That is the problem with graph and tables. If slightly out of domain or something, y min negative 20 to 20. I'm just guessing here. Let's go 6. So first stationary. So what happens is particle goes to there, then decides to change direction. So it's first stationary at 2. All right. Absolute maximum of the function. So probably the easiest way to do absolute maxes is to use fmax. So calc fmax, feed it the expression 6x squared take x cubed. Variable is x between -1 and 5, and it will just go hunt for the highest possible value, which is 32 at x equals 4. When does this curve have a gradient of 4? Okay, well, let's find out. We'll diff that function. And solve that. And we're just basically asking the derivative function, for which value of x does it have a gradient of 4? It's when it's x is equal to 5. And it's a pretty good, so that's the only answer actually I was going to say. Yeah, so it has a gradient of 4 at 5, 0. Right, the graph of that has a asymptote at, so basically that is a reflection, and so it's like basically log 10 negative x take 4. Negative, positive. Okay, so yeah, if you want to sort of picture this graph here, it's asymptotic along there, and no, it's along there, is it? And it goes like that. Let's just check it. 0, 4. Yeah, that's it there. So no, not there. All right, so that's going to mean it's got an asymptote at or along the line x equal 4. So gone. The x-intercept is going to be between 0 and 1. I think I think that's the answer there. Could be that one there. What we'll do is we'll just find out log 10 4 take x equals 0. 10 to the 0 is 1 equals 4 take x negative 3. Yeah, it's definitely that one. Okay, yeah, good problem here. So you just need to know the rule. So to get the derivative f dash x, what we do is we subtract 1 from this and multiply. Okay, so power goes down by 1 and multiply by the power. So it's going to be n take 1 k x to the n take 1. Where is that? Power goes down. So if we've got like 2x to the 4, I'm getting Year 12 integral calculus mixed up here. So 8x to the 3. So it's going to be kn x to the n take 1. Yeah, that one there. Okay. You multiply by n first and then take the power down by 1. So there you go. Nearly stuffed that one up. Okay. here is the graph solution to when it is greater than 0. Okay, so it's going to be between, actually, it's just going to be from when x is greater than -1 and x less than 4, and from 4 onwards. All right, so yeah, I think it's this one here. -1 to 4 and 4 to positive infinity. Yep, it's definitely that one. So that basically excludes the stationary point because it's 0 at that point. Okay, so we've got function f of x and its transformation g of x there to the following. Okay, so what we're doing is we're functions and its transformation. So the function started at f of x and it's turned into g of x. And if you can see here, what's happened is it's been reflected in the y-axis to become sort of like something like that. And then it's been dilated by a factor of something from the y-axis and it's gone down 1 unit. Okay, so we're looking for something like that. And D looks like your answer. A reflection about, no. E, maybe. A reflection about the y-axis, followed by a dilation factor of a half from the y-axis, and translated 1 unit in the negative direction. Yeah, that's it there. All right, so there's your multiple choice section. So some fair bit of calculator use there. But for a lot of those questions, yeah, if you can draw the graph or quickly cobble together your thoughts or ideas, you really don't need to go to the calculator for a lot of those questions.